Okay. All right. Hello. Hello, everybody. This is Genesis Gur with another stream. Or if you guys watch me on Twitch, I go by Otaku. But I go more so by Genesis. So this stream, I'm actually going to be going over the process of computer vision. And computer vision has to do a lot with identification and detection, and it's going to be really fun. We're going to be doing this in Python, and I do want to say that in this stream, I have not got anything prepared yet, so you're going to see me working with computer vision on scratch. I also want to say most of the things that you do see me on streams, my past two streams were me giving advice and everything like that. I don't really want my streams to always be like, like tutorials or anything. That's not the aim. The whole idea of my channel is to just keep an archive of my workflow. That is the main thing. So sometimes on stream, you might see me just not explaining things a lot, but I do go through my workflow and I do explain. Yeah, so with that said, yeah, let's get into it. So I was having some trouble with oh, by the way, new wallpaper. New wallpaper today. This is the wallpaper. Now I am gonna have anime wallpapers, as you guys know. This is my wallpaper today. But I got something over here prepared. Over here. So I figured out why my CV2 wasn't working. I had to make sure my CV2 was actually working before I actually started to stream. And I found out what the problem was. So if you're using Python 3. An older version of Python, I cannot tell you which version it is. All I know is I was using Python 3.5, 3.10.5, and my CV2 wasn't working. I'm pretty sure CV2 works in Python 3.10.6. I'm not sure. But I had to switch over to a version of Python 3.10.11. No, 3.11. So for this instance here, for this, for me, in order to work with this version of Python, I'm gonna have to be using what's it called, and the most updated version of Python. So with that said, let's get into this. This is a simple script. All this script does, it just displays images. This is not what we're going to be doing. This was just a little thing that I got, as you can see, this program pops up an image. It doesn't matter what image that is. It names it. You can name the image, whatever the hell it is. Well, the border. And this is a picture of Robbie. She's an actress. And we're doing that with the I'm show method or function. I'm sorry. And this function, as it says right here, it'll display an image in a specified window. If the window was created with CV, window auto size flag, the image is shown. And I think we're not doing, hold on, let's see. The window name, we have Marnie. We can change this over to Robbie now. Some image, I don't know. And as you can see, when we do this, now we look really closely, it'll say some image, I don't know. Right? Cool. So, but this is one of the very few things that you can do with CV2. With, we're gonna do some way more cooler things, and I will get to that in a minute. So we're going to go ahead and close this. I'm sorry if you hear me sniffle. I'm getting a little bit sick. I'm recovering from I don't feel bad at all, but I was sick like 4 days ago. So let's go on. Let's go put some... Actually, we don't even need music, honestly. We're going to open up a brand new file. We're going to call this, I'm going to save this file. This module, we're going to save it as, I don't know, CV2 face. I don't know what to call it. Let's just call it XKO with a bunch of numbers right here. .py, and we're going to save that over here. CV2 sketches, we're going to go here. We're going to save it in here. Great. Copy this. Boom, boom. We actually might actually play some lo-fi. Not even gonna cap. Just try to find a good image, one that I always use. My signature ASCII. What if I check this? That's what it is. Face recognition. I think I spelled this wrong. I'm sorry. Let's see. I actually spelled that right. I actually spelled ethnicities right. That's actually surprising. and we're gonna go put a little example part here because I do actually want to come back and do like an example. Sorry, I'm trying to get my mic at a good angle. Okay, let me mute myself on. Okay, so first off, the first thing I'm going to do, I'm going to go ahead and actually import CV2. So we're going to import modules, import CV2 as CV. Right? It doesn't matter. But in this case, we're just going to import as CV2. Right? And if we hover over this, it tells us open CV Python binary extension loader. Now, we are going to use ChatGPT to refresh me on what some of the features are. So let's go ahead and see. And what we're going to do, we're going to pretty much ask ChatGPT what is open CV in Python to get a big understanding. There's nothing wrong with getting information from ChatGPT. It only becomes a problem when you do it, you rely on ChatGPT all the time, if that makes sense. Like, no one's gonna kill you if you, like, you know, want to ask ChatGPT a couple questions. It's not gonna kill you. You know, if someone says, oh, we'll use ChatGPT, like, it's fine. It is a tool. We use tools, but you can abuse tools. And we're not going to do that. So the first question we're going to ask is, what is OpenCV, or better known as CV2 in Python? OpenCV, Open Source Computer Vision Library, is a free and open source computer vision and machine learning library. It was developed by Intel and was later supported by Willow Garage and now maintained by ITSEs. The library provides a comprehensive set of tools for image and video processing. Just as we described back over here, CV2 stands for computer vision, we got that right, and is a third-party module that allows the ability to manipulate image and video data. Yeah, so, you know, at the end of the day, this right here was my own explanation of what I've known in the past, and you kind of want to, this is why it's okay. I use ChatGPT as a dictionary at times. I don't use it as to get answers. All, like, I guess give me full-on code, copy and paste code. You don't want to get into the habit of doing that. So the first thing we're gonna do, we're gonna like that. And that liking, you know, responses from ChatGPT helps ChatGPT knows that it's doing a good job and gives us a better algorithm, a better algorithm the next time to find a definition. The library provides a comprehensive, yeah, I already read that for, we read that. Object detection, face recognition, image segmentation, and more. In Python, OpenCV is commonly used through its Python interface, which is called CV2. The CV2 module provides functions for many of the operations available in OpenCV. allowing Python programmers to easily incorporate computer vision algorithms into their applications with the help of CV2. You can read, write images and videos, perform various image processing operations such as smoothing, edge detection, and thresholding, and implement advanced computer vision techniques such as object detection and tracking, and much more. As you can see, this actually gives us a lot of abilities, and you know, there's a lot of features in OpenCV. There really is. I mean, object detection, all the stuff that they mentioned before. I'm going to mention them again right now. So with OpenCV, you can manipulate image and video data for processing, or just, you know, manipulate videos and images, object detection, face recognition, image segmentation, and more. We can ask ChatGPT what's and more. We're not going to go too deep into that because today we're just going to focus on face recognition today, and we're going to make a script on this, and then I'm going to go back on Twitch, and then I'm just going to study a shit ton of stuff, you know. When I do come on YouTube, it's going to be for like stuff like this that I feel like I deem really important. I feel like every programmer should have the ability to, you know, object detect. Like, if you can't object detect, what are you doing? First of all, like, come on. And if you don't know how to face recognition, this is great stuff. You gotta know this, you know? You have to know this. So let's get into it. What's the first thing we're gonna do? First, we're not gonna ask ChatGPT how to do this at all. We're gonna try to figure it out on our own. I know that's really stupid. But here, we're going to just ask ChatGPT what are all the functions and methods that are available in OpenCV. What are all the functions and methods available in CV? OpenCV provides a wide range of functions and methods for image and video processing. Okay, so here's the core functions. The core functions, these functions provide low-level image processing capabilities, including image loading, saving, pixel manipulation, and basic arithmetic and logical operations. Image filtering, enhancement functions. These functions perform a variety of operations on images, such as smoothing, sharpening, edge detection, thresholding. And then we have feature detection and extraction functions. These functions identify and extract features in images, such as corners, edges, blobs, which can be used for various computer vision tasks. And then you got object detection. Object detection. Tracking functions. Not just, pay attention, object detection and tracking functions. So that means that when we say object detection, it will detect something, whether it be a cup, whether it be a bird, a human face, anything you can imagine, a bottle of soda, anything. It will detect it if you program it correctly, to my understanding thus far. Now, when we talk about tracking, this right here is definitely really cool. You actually get to track the object in real time, whatever that object may be, whether it be a person running across a field. You could really hone in on that object and track it in real time. Or even if it's a video, let's say if it's a video, you could still track it then, even if it's a live stream. This would be more so effective if it was a live stream, but you could do this on a pre-recorded video as well. You could still track things on a pre-recorded video as well. Cool. And we're gonna read this part. These functions detect and track objects in images and videos, including face detection, object detection, and object tracking, machine learning functions. Okay, so OpenCV has machine learning. How cool is that? Machine learning capabilities. Let's see what that means. OpenCV includes machine learning algorithms. And algorithms is just a fancy word for a way to do something. A strategy, you know? The way you open a door, right? You can open the door really fast or really slow. Those are two different algorithms. The slow algorithm and the fast algorithm. So that's what algorithm means in the long run. Classification, clustering, and then we have camera calibration functions. These functions help calibrate cameras, correct distortion, and calculate camera parameters. And then we have video processing functions. OpenCV provides functions for video capture, video processing, and video playback. How amazing is this? That one module, which is OpenCV, and this is available in other programming languages as well. This isn't just for Python. This is available for other things as well. If you use your mind and you really focused and really use this for in a very creative way, or just for fun, or as a hobby, or more so to just get your feet wet and have an understanding on how this works, you could learn a lot on how Python is able to actually capture images, detect. This is one big arsenal. I love OpenCV, and we are going to be fucking with it this entire stream. Yeah, so you can record video with this. You could process video with this, and you can actually play back video with this. Did you know, for all of my future subscribers or people on Twitch, did you know that OpenCV was actually used, was Python used in the expedition to Mars? Python helped in the first pictures of the Martian surface to Earth 4 minutes after landing. As it happens, this programming language was quite important to the mission. 5 cameras were positioned in various locations around the probe, captured the landing itself. So this means that Python played a huge part in the Mars landing, capturing images, detecting little rocks and little pebbles, finding what it could. And at the end of the day, the Martian mission was to see what was on Mars, right? If there's any signs of life or whatever, because that's what it was. The whole idea of the Mars mission was to find signs of life. And we found a bunch of dust, right? But there's a lot of other cool stuff that's on Mars, you know? There's even talk about, like, there used to be like water on Mars. Excuse me. I'm on the phone with my girlfriend. So yes, Python did play a huge role. So let's go back. Did OpenCV and Python play a role in the Mars landing for NASA? Yes, OpenCV and Python played a role in the Mars landing for NASA's Mars Perseverance rover mission in February 2021. OpenCV was used to process images captured by the rover's cameras during the landing process, and Python was used to write the software that processed these images. During the landing, the rover captured high-resolution images of the terrain below it, and these images were used to guide the rover's descent and avoid hazards. The images were processed using a vision-based navigational system called Terrain Relative Navigation, or better known as TRN. which was developed by NASA's Jet Propulsion Laboratory JPL, excuse me. The TRN system used computer vision algorithms to match the real-time images captured by the rover's cameras. So that's how it works, right? CV2 works in cohesion with a device too. So you can connect CV2. You can in tandem use CV2 with the camera. You choose the web camera that you want to get a feed from, and CV2 does all the magic behind the scenes there. So, but you don't even need to have a camera to use CV2. What if I told you you don't need to have a web camera or anything like that to use CV2? You can simply go to Google, look up a picture of, I don't know, Harley Quinn, actor. Find a picture of Harley Quinn or any picture on Google, pick one, and it will actually analyze the picture, whatever you choose, doesn't matter. Let's say an image like this. CV2 will actually analyze and tell you the race, the age, the gender of this person. And we're going to do that right now. We're actually going to go hop into Python and see what that's like. She looks very devious. She looks like she's ready to kill someone. And so does this one too. Yeah. What movie was this? I don't remember what movie this was. A Suicide Squad. Great movie, by the way. Overall, OpenCV and Python played a critical role in the success of the Mars Perseverance rover mission by enabling the TR system to accurately guide the rover to the landing site. So, technically, for anybody who says, well, Python shit, if it wasn't for Python, we probably wouldn't have never seen images of Mars at that time. So, in my honest opinion, I like every programming language. I don't want to say that now, but I really do enjoy every programming language. So Python, so if anyone out there is like, oh, I don't want to get into Python because of, oh, well, a lot of people do not like it. Guys, Python is very powerful, okay? And some of these people, they don't even try Python. They've probably never even programmed. But anyway, let's get into this. So we're going to ask ChatGPT, could you show me an example on how face recognition works with OpenCV in Python? Sure. Here's a simple example on how to perform face recognition with OpenCV in Python. So, first we have their importing. Now, this is really important. We're not going to copy and paste. We're not going to do that. What we're actually going to do, we are going to read line by line, and we're going to learn. Take our time. And this is actually kind of different than how I did it before. So we have, let's read all the steps first. We have load the pre-trained face detection model. Yep, that makes sense. I remember that. We actually have to load a detection model that we're going to use. There's different types of detection models out there that you could use. But more so, it doesn't really matter. Some detection models are better than others, but we're just going to go with what the script says. So that is correct. We do have to load a face detection model. Step 2, we have to load the image and convert it to grayscale. I don't remember like loading it, making it grayscale. I think the reason why we make it a grayscale is because I guess it makes it easier for the detection to handle that better, we'll ask it. Let's ask it right now. Why must we convert it to gray? Why must we convert the image? And these are genuine questions that I'm asking. I really am asking it this question because I don't know. To grayscale. My assumption is because we'll make the detection model analyze the image better. This is my assumption. I could be wrong. I honestly think the reason why we have to convert that image to a grayscale, like make it black and white. So an example, let's go over here to deep face sketches, an image of, I don't know. Here's an image, or okay, we're having an error. Okay, I don't know why we can't open up these images. Error loading, blah, blah, web error cannot register service. Okay, we're gonna have to reopen this. Let's open this shit up. There we go. All right, so here we have Breaking Bad. Let's make this completely like this. So I feel like the reason why why it wants us to make this black and white. Now hear me out. What if the colors and the pixels make it harder for the face detection model to actually analyze the picture as a whole? That is just a guess, you know, because it's extra work that it has to do. Well, let's go figure that out. Let's go see if I'm right. I could be wrong. Guys, I'm not right all the time, so we'll see. Yes, you are correct. We're right. I was right. It's just, I don't know. Guys, I swear to God, I didn't know that, but it's just common sense. Yes, you are correct. Converting the image to a black and white or grayscale is common pre-processing step when using computer vision algorithms, including face recognition. The reason for this is that grayscale images only contain single channel of information, intensity, whereas color images contain 3 channels, you know, RGBA, we all know that, red, green, and blue. By converting a color to grayscale, we simplify the image and reduce the amount of information that the face detection algorithm has to process, making it faster and more accurate. In the case of face detection with OpenCV's hard cascades models, converting the image to a grayscale is a requirement because the algorithm is designed to work with grayscale images. The Haar Cascades algorithm uses a set of features that are based on the contrast between light and dark regions of the image. And this is seen, right? Because in like some examples that I've seen before, I've seen that some images that are, you know, I've watched tutorials and some people would make it black and white, and I never really understood why, you know? Like, why would they make it black and white? And then I was like, oh, it's to, you know, make it more to make the process of processing images less difficult, right? And you know what? We're gonna do something fun. We're going to process hold on, I gotta sneeze. We are actually going to process real human beings. We're going to do face detection with real humans, and then we're going to do what? We're going to process anime waifus and tell their age. I'm really curious to see what the fuck it's gonna say. So if you guys want to watch that in this stream, we're going to do that. We're going to detect humans and anime chicks today with OpenCV. So I'm really, and Charlie Sheen. And Charlie Sheen as well. Why not? He'll be one of the people that will face detect. So let's go back to the original one that we created. Let's go back to this one. Okay. All right, ladies and gentlemen. Fuck. All right, so first things first. What's the first step? So stage 1, choose a face detection model. Algorithm, right? So that's the first thing we're going to do. So we're just gonna use, since we're gonna be using face cascade, it's gonna be face cascade is equal to, and it seems as if, yeah, you see how we're breaking it down line by line? That's really important. So we're actually going to load the pre-trained face detection model. We're not going to copy any of this. We're only going to copy the things. We're really not copying anything. We're really trying to see what everything does. We want to have an understanding. Most people, what they do, please don't do this, guys. Please, if you're watching this, please do not be this guy. Boom. Copy, paste, boom. End of story. No. You got to break it down line by line. So look, by memory, CV2, module, cascade, classifier. I feel like that is the one. And then this probably takes what? What does this take? Classifier. Okay. So we have this here. And then we have har cascade underscore frontal face underscore default dot xml. Let's ask them what this is. Let's ask them what this is. I have a question. We don't even have to say that because we get a limit. We have a limited amount of questions we can ask. What is the string inside of the classifier, and what is it pointing at? And what is its purpose? The string har cascade frontal face default.xml is the path to a pre-trained har cascade classifier XML file that contains the machine learning model for face detection in OpenCV. This file is a part of the OpenCV package and can be found in OpenCV data har cascades directory. So this is just a way to, so what is this? A pre-trained, so this is a detection model. Correct? Yes, correct. Cascade classifier object that the cascade classifier object that we create with the file is a pre-trained machine learning model. What if I want to use third-party pre-trained machine learning models? Can I? Yes, you definitely can use third-party pre-trained machine learning models in OpenCV. Nice, that's cool, guys, because you know what that means. That means we don't have to be hard coded to use just the and you have to remember, like, I don't like that they don't have see real world examples. Here's the, okay, so here's the one that comes built in. So we're gonna copy this. So this is going to be the one that we're going to be using today. We're going to be using that. I'm going to copy this in chat if you guys get curious. Oh, hi. Hello, Poflo. I don't know why I didn't get your message. Very strange. I don't know. I should have got your message. Weird. But welcome to the stream. Right now, we are working with open source computer vision. We're about to do some really cool stuff right now. Try to keep up with me, because I'm going to explain this as best as I can. It's very simple. It's not very intricate at all. But it can get intricate if you don't know Python as a whole, right? But I'm going to try to make it as fun for anyone watching and anyone rewatching in the future. But all we're doing right now, I'm going to read this over one time so you guys can know what is OpenCV? What does CV2 stand for? It stands for, let me make sure that messages are going through. Okay, let's double check. Settings, appearance, notifications. I don't have TTS on. I don't think I need that. There we go. All right, cool. Open source computer vision. CV2 stands for computer vision. Now, I'm going to tell you guys, we're going to go over here. We're going to read all the way from the top. OpenCV, or better known as Open Source Computer Vision Library, is a free open source computer vision and machine learning software library. It was developed by Intel and was later supported by Willow Garage and is now maintained by ITSEs. Long story short, let's see, what are the main functions? Blah, blah, blah. I'm gonna try to find one that actually breaks it down. Let's see. Here we go. The library provides a comprehensive set of tools for image and video processing, including a vast collection of functions for tasks such as object detection, face recognition, image segmentation, and more. So what does this model do? What does this module do? It detects objects, it can track objects, it can detect faces, it can manipulate images and videos. It's one big ass arsenal of power. If in that sense, it's one module that can do a lot of things. So this is very interesting. Yeah, so I remember you were talking about that you wanted to get into robotics. I wouldn't be surprised if some of the robots today implements OpenCV, because with OpenCV, your robot, essentially what you're trying to build, you could be like, okay, this is the distance from the wall to me, so it won't, crash into things, because it can detect tables, chairs, anything really, cups, objects. But with that said, we're going to go ahead and actually build this thing now. And let's go over here. So how do we start this? First things first, you need to import CV2. That's going to contain all of the modules that you, all the functions that you're going to need. Second, the first stage is to choose a face detection machine learning model algorithm. Let's put that in there. Machine learning model algorithm. So what does this mean? This is just the way we're going to detect things. This is going to be the model, the machine learning model that's actually doing the processing. So face detection, pre-trained, face detection, pre-trained machine learning model algorithm. I know that sounds really crazy, but just stick with me here. And then the next thing we're going to do, this step is done. We can go on to loading the image and converting it to a grayscale. So what does this mean? We're going to boot up the image that we want to use, and we're going to make that image black and white. Why is that? So I want you to look at this picture here. This is an actress, right? What do you notice about this picture? It's a girl, it's a woman. There's a lot of colors going on, and that's great. But when it comes to like modules and stuff, when it comes to pre-trained models, the one that we're about to use specifically, some of them are built and created to not work with colorful images like this. It stresses out the model. It makes it more harder for the model, and it's more prone to errors. So we might even get like at our output, our final result might be like, oh, this is a man, they're Hispanic. No, we might get an error. So to avoid that, we are actually going to convert this image from color to black and white, aka grayscale. Does that make sense? We're going to make the image black and white, so our pre-trained model, machine learning model, can handle it better, more stress-free, and more reliable, because it works on one field, which is intensity. Now we're going to call this image. We're going to say CV2 dot, let's see if we can find it. I might be getting that wrong, but let's see. Image CV2 I'm read. So we're going to use the CV2 I'm read file name, and we're going to go ahead and put this now. Now this is going to be the file that we're going to actually use and convert. And then the I'm read function comes with flags. It has some flags here. File name. So let's go use, let's use her, right? Let's use Robbie. We're going to copy the path, the relational path. We're going to go here. Boom. Great. We're done here. We've loaded up the image. We're using the I'm read function from the CV2 module to, it tells you right here, the function I'm read loads an image from the specified file and returns it. If the image cannot be read because of a missing file or improper permissions, unsupported or invalid format, the function returns an empty matrix, which is mat data is equal to null, right? And we all know what null means. Do you guys know what null means in programming? It means nada, nothing, right? Or none in the sense of Python. Let's see. What's next? Gray. Okay. So we're gonna call this gray image. We're gonna call it gray image. Let's call it gray IMG. So we're going to CV2. CVT color. I'm guessing. And what is this? You should never source material. So I'm guessing the source material is the code, blah, blah, blah. Let's see. CVT color, I was correct. So the image, CVT2, color, background to gray. All right. Now, we are not copying off this code. What we're doing is breaking it down line by line and understanding it. And that's the way I learn, right? Like everybody learns differently, But me, myself, I like to break things down and have an understanding. This is called reverse engineering. No one's going to kill you for reverse engineering a piece of syntax or a piece of code. If someone tells you, we're not even going to get to that topic because that's just, it's not important. What's important right now is that you learn, right? And the way you learn is by ripping things apart and taking them apart. That's how you learn. And by studying. So let's go ahead and do this, right? So source, what is, let's go see what source means. Input image. So the parameter src is the source input image, an 8-bit unsigned, 16-bit unsigned, or one or single precision floating point. So let's go ahead and put that down. And we're gonna put image. I put ima. Boom. And then now we're going to say, what's the second one? We don't know what the second thing is. CV2. Oh, okay. So CV2. Let's see. Well, let's go read. Code. What is code? Image. Oh, okay. So param code, color space conversion code. So, okay, so I'm guessing this right here is the way, this is where the conversion's actually happening, the way we're going to convert it. So code is equal to CV2 dot color background, and then I think they said to gray, to, I think they have it. Color background. Oh, and then here we can actually set the backgrounds. Look, we can set it to all different types of things here. But the one that we want to set it to gray. Okay, that's not the right one. We want to get the right one. Layer. We want background. See if we can find it. You know what? For now, BGR. We just want this tag here. Let's try to remember it. So it's color underscore BGR 2 gray. There we go. All right, great. We have loaded up our image. Load image. We can actually break these down into smaller parts. We're going to load image. All right, and we're converting. All right, so we have 3 steps so far. What's the next step? Now, I guess this is going to be the fun part. Detect faces in the image. Now, this is going to be actually us detecting the faces in the image. Draw rectangles around the detected faces. Now, this is right here. Draw rectangles. We could skip this. We don't have to do that, right? But, you know, let's see. But we'll do it. Why not? We'll do this. So detect the faces in the image. Okay, let's make this a little bit bigger. Faces. Faces is equal to CV2 dot is equal to face cascade. Okay, so it's, remember, because we're using that. Face cascade dot. It seems as if we're not getting a face. Oh, because I didn't put the underscore. No, I did. We're running into a problem here. Let's see if we get an error. Let's actually copy this entire thing and see if we get an error. Gray is not defined. Gray image. Okay. So we have this, detect faces in the image. We're going to comment this out and we're going to try writing it ourselves, okay? It's equal to face underscore cascade dot detect multi-scale I don't even know. We'll see if that even works. We'll see. Yeah, we'll see if this works real quick. Next, we're going to draw the rectangles around the detected faces. So this is how it's going to do it for X, Y, W, and H in faces. CV2 rectangle. Okay, so let's do that. So we have a for loop. So now we're going to draw the rectangles around. So this is going to be the for loop for X, Y, W, and H. In faces, this is what's going to happen. I want you to CVT rectangle. We could just put that CV2 rectangle. Okay, part 1. As you can see, they do take... Give me 1 second. 1 second. Okay, I'm back. Sorry. As you guys could tell, I was getting called. They were asking me for things. We're gonna turn off this music right now. So this is really interesting, right? I'm not gonna lie to you guys. This is different than what I did before, but this is gonna be really cool, right? And then we're gonna analyze this code and see what it does. I already understand this part, this part, this part, this part here. This part here, I really don't have a big understanding on. I wish that they can. We're gonna tell them to return us the positional parameters. Insert the positional param names with the arguments, please, so I can identify which ones they pair up with. Here we go. That's better. Okay. This updated code, we've included the names of the parameters being passed to the CV2 rectangle function. What does the CV2 rectangle function do? Stuff like this. Ask it stuff like this. That's what ChatGPT is for. It's not for write me an essay. Do this, do that. It's not for that. It's for asking it stuff like this. Okay, so the rectangle function in OpenCV is used to draw a rectangle on an image. That's it, right? And I'm guessing these, you know, obviously the image is the input image, which we're going to draw the rectangle on. So we're going to do the image parameter, and the image we already know is going to be image. The next one, see, we're starting to break it down. PT1 stands for a tuple representing the top left corner of the rectangle. And we have PT2, so point 1, point 2, color, a tuple representing the color of the rectangle in BGR format, and thickness of the rectangle lines. Default is 1, right? So we have the point 1, which is the tuple representing the top left, and then we have the tuple representing the top right as point 2, and then we have the color, which can be pink, blue, red, doesn't matter, and we have the thickness of that actual rectangle that will be on our input image, which will be this. Guys, we're probably gonna have an face detection output of a rectangle around her face. Maybe it'll be, you know, this small, who knows. If it's really tight right there, dude, I'll be really, really impressed. But if it's like out here, then I mean, no, I don't think so. I think it'll be like right here, like boom, 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 something like that, right? So now we're gonna do point 1 is equal to, put none for now. Let's put point 2 is equal to none for now. And then we're going to put color. Now, we can actually determine a color. As you can see, we're going to say CV2 dot color background BG. I don't know. They don't show us the color, unfortunately. So I really can't. Okay. Oh, pink. Here we go. Here we go. We have autumn, cool, deep green, hot, inferno, magma, pink, rainbow, turbo, twilight, winter.
color change, and then dot. No, I'm just doing some experimentation. Yeah, I don't know. I want this to be red. Okay, my girlfriend is. I'm awake. Okay, hello.
Hi, my loves.
Hi, my loves. They'll be able to hear you because I'm actually streaming right now. Okay, and this is on YouTube. Okay. Okay. So let's see. Let's go down. I'm gonna try to find red. And good morning, by the way.
Good morning, my loves.
Happy Mother's Day.
Thank you, my love.
You're welcome. I'm having trouble finding red here.
On what?
I'm doing open CV2 right now. If you want, or you want me to call you on Skype so you can be a part of it now? Okay. All right. Well then. Okay. Well, I gotta concentrate right now because I'm doing this right now. All right. So need to go find red. Let's go see. Let's see. I don't know. I don't know which one is red. We're gonna leave that out for now. But I feel like they probably provide that to us here. Let's see. Let's go back up. Okay, you guys might hopefully you guys can't hear that. Unfortunately, you guys will be able to hear this music. You're gonna have to deal with it. I'm sorry. If you guys hear music in the background, it's because it's Mother's Day, okay? But just deal with it. Let's see. Okay, so X and Y. X plus Y plus the... Okay. So we have the image. So this is 0.1. So we're going to put the tuple. So these are two tuples that it's taking. So this... The 0.1 takes a tuple. 0.2 takes a tuple. So 0.1 is going to take X and Y. And 0.2 is going to take W and H. So you're probably wondering what this means. This means technically the 0.1 parameter is going to be the top left of the corner, the position of where that rectangle is going to be on this image. And 0.2 is going to be the bottom right corner. So if that makes sense, here, let me show you. We're going to do this. We're going to do this. Look at this blue text. Try to ignore the anime girl for now, okay? The top left right here, that's point right here. That's going to be the 0.1 parameter. And all the way here at the bottom right, that's going to be making the bottom right of that corner. And I apologize for the fucking anime girl, but yo, you already know me, bro. You already know me, but fuck. Hopefully that makes sense. Let's see. Plus, all right, we can do this. X plus W. So it's X plus W and Y plus H. And with this, I think we're done. After I do this, guys, I'm probably going to get off stream and I'll stream again, but I'm not going to stream on YouTube because this music is getting really excessive. And then here's the color values for the code. We're just going to grab this. What is this? I don't know what 2 is. We have this part here. Image, 0.1, 0.2. He explained it down here. Color. Okay, so this is the color that we're going to be using in RGB. Oh, so here, guys, you want to see how much I know my shit and why you should guys listen to what I gotta say? How much you want to bet that the green border, the green rectangle, is going to be completely green? It's going to be green. I call it right now. And if you guys know why, let me know in the comments below. All right, so let's go back over here to the code. The color. Make this a tuple. Boom. And then the last value is the thickness. We want the border to be 2 inches big, or 2 pixels big. I don't know. See? Which is the thickness, right? Boom, we're done. We can actually put this down here. Go over here. Now for the easy part. We just display the image with the detected faces, right? So we're gonna do that with the CV2 I'm show. Okay, and images, all right? So let's put this here. It's Mother's Day, guys. Happy Mother's Day to anyone out there. And if I'm not responding to you guys' messages, I'm sorry. I'm not getting notifications right now. I don't know what's going on. All right, so let's go over here. CV2 dot I'm show. What parameters does this take? A win name and a material name. What is the win name? Name of the window. Okay, so the first argument is the name, and the second one is the image to be shown. So we're just going to put that down there. We're going to call this faces, and mat is equal to gray image, I would say. Right? All right, I think with this said, and then these last two is wait key. You know, you guys want to know what this does right here? The CV2.wait key is going to wait until we press a key on our computer, on our keyboard, excuse me, and it'll close the actual window. And then CV2 destroy all windows. It's going to destroy all the windows after that. So we can just actually write that. What was it? Wait key. It's going to be 0. And CV2 dot destroy all windows in this function. And we're done. Now, here we go, guys. I'm going to play some music. And we're going to test it out. Let's see what we built. Play some music. Okay, we get an error. We're getting an error so far. Can't open file, blah, 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 in read mode. Let's go back. Let's go tell ChatGPT that. Yeah, we're gonna need... We don't even have a relational path. That's the problem. You see this? This is Okay, let's see. Let's go find this file. I'm gonna mute myself. All right, we did it. All right, so since this is on YouTube, so the problem I wasn't having problems with actually coding it itself, right? I was having problem with I couldn't find a path to this actual model, to this face detection model, har cascade. So I had to make sure to use CV2.data.har cascades to actually point me to where the actual location is, so we can even use it. So this works now. So if we actually go ahead and run this, we can close this, we can run this, and as you can see, it detects the face, and it's spot on. It's right on her face, dude. And it's detecting a face. You know how cool that is? That's really, really cool. Now, this border, we can make this border line thicker, and we can change the color of the border, right? Now, I want you to imagine if this was a video, and she was walking. This rectangle, this box, would be following her in real time as she's walking through whatever she's doing. That is fucking awesome, yo. So, there's that. So the last thing we're going to do before I head out is actually going to change the color of that actual, we're going to try a different image to prove, we're going to try several different images to prove to you guys. We're going to do two things. We're going to change the image. We're going to do a Breaking Bad one, and we're going to use all these images. And as you can see, they're on different, positions of the screen. I mean, their faces are on different positions. And then we're going to change the color of the rectangle, right? Just to have that for whatever reason. So yeah, I'm sorry I didn't have my mic on like around the end. I mean, you guys can hear the Spanish music going on. If that's not proof that I'm not Spanish, you know, if that's not proof that I am Spanish, you know, I don't know. I just sound like a gringo. That's all. Alright, so let's go ahead and do this. What are the RGB values of... What are the RGBA values of red?
According to W3 schools,
Obviously.
example, RGB
That's a dumb
is displayed
question.
as red because red is set to its highest value and
Its
the other
highest
two
value,
are set
yeah.
to 0.
Yeah, that was a dumb question, to be honest. So now this should be red. And I was wrong initially at first. I thought it was going to be green. So it's RGB. I don't know. We'll see. Let's close this. And we get white. I wonder why that is. You want to know why? Because it's gray. It's converted to gray. So, that's probably why. You know? If we want to convert make the rectangle actually red, we would actually have to do more processing on top of that. But with that said, let's actually try some different images. And they can't hear you, my love. No one can hear you. You can talk. Let's see. Where's it at? Where's it at? Marnie. Here, let's use the image of Marnie. Copy relational path. So we're gonna leave it back on green. Because that is probably green. It is probably green. It's just showing that like that. Let's see. So here's an anime girl. Okay, it somewhat got it right. We can actually zoom in. Can we zoom into the picture? Yep, it got her face right there. Got a little bit of this, but it did get this region here. Let's try a different one. Let's try Charlie Sheen. All right, let's go ahead and run this. Yep, it got Charlie Sheen's face. Perfect. Nice. As you guys can see. Cool stuff. This is face recognition that you guys are seeing right now. And this was used in a lot of computers use this, a lot of software use this. The Mars mission used this, but it detected rocks, I'm pretty sure. Yeah, rocks and pebbles and stuff like that. But look at that. That's detecting that. And the next stream that I do, when the music is not blaring like a mariachi band in here, we're gonna do... I'm gonna eat good. That music's a good sign, though. I'm gonna be eating good as fuck. But we're going to detect race, ethnicity, gender, all that stuff. And I highly encourage you guys to rewatch this. I really want to apologize for the music, but go rewatch and see how I made this from scratch, because now you guys have an actual YouTube channel where you guys can see me build stuff from scratch and see how it all goes down, you know? And I'm going to remember this forever. So let's see. Let's go down to Sammy. Let's grab her. It's a random image off of Google, in case my girlfriend's watching. Don't know who the fuck this girl is. Alright, here we go. Boom. Now, how strange. Do you guys see that? It detected a face in her cup. Weirdly enough. Do you guys see that? Let's make this a little bit bigger. It detected a face in her cup. That's... See? It's not 100% reliable. You know, all the time. But there are better, really good models. We are using the default one. And the default one is, well, default. There's way better ones that could just detect faces on its own. But that's definitely not a face, unless there's like a ghost in there or something. So let's go on to the last one. Breaking Bad. Heisenberg. Go ahead and copy relational path. Oh my god, there's a fly in my room. Alright. Boom. Yep. It identified his face spot on. And I'm going to zoom in so you guys can see. Right on his face. Cool. Really cool stuff. The next stream, guys, I promise to give you guys a more, less interrupted stream. And yeah, with that, I'm out of here. If you guys enjoyed this, make sure to like, subscribe, all that other stuff. And yeah, I stream on Twitch. I'm on Twitter. DM me on Twitter, anything like that. I do want to say in the future, I do want to get into some, I want to get into physics, quantum physics, mathematics, arithmetics, astrology, all that stuff on my channel. And with that, I am out. And as everyone else, he says, a ghost. Ah, I want to do that. And I will teach you. By the way, Poflo, I'm sorry I was not ignoring you this stream. I'm not getting notified, which is weird. But next stream, I'm gonna make it so I can actually... Oh my god, that's so cool. It is very cool, isn't it? And this is what... Next stream, we're gonna do this all over again, right? So let's do this again. Let's do something even more cool, right? Here, we have a face. Let's take a screenshot of Poflo's text. And let's see if this face recognition can identify a face in this text. Oh, that's really cool, right? Is that possible? Yes, it's possible. Let's see. Let's see. Guárdamelo, por favor. ¿Tú me lo puedes guardar, por favor, amigo? Okay, thank you. And happy Dia de la Madre. Okay. Sorry. As you guys can tell, it's really hectic over here. But even on Mother's Day, I'm giving you guys really cool shit. So let's go see. Let's go save this in pictures. Let's call this PoFlow text. All right, PoFlow, let's see. That text. All right, here we go, PoFlow. So now we are going to go grab this pictures. We're going to go to PoFlow. Oh no, PoFlow.png. I'm sorry. Change it. There we go. Is this valid? Oh, I broke it. Let's try this again. I'll just save it like that. PoFlow.png. Okay. PoFlow.png. There it is. Let's grab it and let's go put it in deep faces. See, and now we have this over here, right? We're gonna put this down here. We have this now. Do you think that we will be able to actually identify a face here? These two faces here. Well, let's see. Let's grab, copy relational path, and let's go see. Boom. Fingers crossed. Okay. Did it find anything? No. It didn't find anything. It seems as if it did not find any faces here. Let's give it let's go on Google and find some more faces. Right? Let's go find anime chick. I don't know. Anime chicken? No. Anime chick. I don't know. Please, Google, don't get me canceled. Let's just go find a random image of a face. Here. Boom. Open an image, new tab. Save image. Save. So guys, as you guys can see, we are going to test this out. All right, here we go. Let's try out this image here. Ready? Copy. So we're copying the relational path and we're passing it to the image that we want to load. Before I leave, I'm going to break this down really fast. Oh, I think I might be doing this incorrectly. No. We are doing this right. It's just not detecting any faces. It's not detecting any faces because this is anime. You know? This is anime. But if we give Charlie Sheen back over here, copy relational path, we'll do Charlie Sheen again. It's good that we're doing these tests though. There we go. See, it detects real people. That's insane. You know, it detects real people faces. It doesn't detect anime or anything like that. Maybe sometimes. But with that said, guys, I'm going to go break this down. And then I'm going to go leave. Because it is Mother's Day. And Poful, I hope you have a good Mother's Day. I hope everyone has a good Mother's Day today. I'm going to go spend time with my girlfriend. And stuff like that. She has to go to church and pray to you know. So we're gonna go over here. So welcome to open source computer vision. It's a module. It's free. If you want to install it, you just use the following command that I'm about to give you right now. To install it, it would be pip install -- user. I think open CV Python. Yep. -Python, excuse me. That's what it would be. So if you want to install this, that's what you would have to use. So for the people who want to know to actually do this, this is how you do it. First, you're going to need to import CV2. You're going to have to choose a face recognition pre-trained machine learning model algorithm. If you're starting out for the first time, use this one. This is the most basic one that you could use. Put that inside of the CV2.cascade classifier. After that, you load the image that you want to do. After that, you convert the image to grayscale because the HAR Cascades model it works better with grayscale. So you would convert that. You guys can just pause the video and take a look at this stuff after I leave. Then you actually have to detect the faces in the image, and you do that with the face cascade.detect multi-scale, and you choose your image, and then there's scale factor. After that, you draw the rectangles around the detected faces with this here. So we have 1, 2, 3, 4, 5, 6 steps, and then the last step, the 7th step, is to actually display the image, and we're displaying the image with the I'm show function, and we're, you know, naming the window name, faces, and then the material that we're going to use, well, the mat. I don't know if that stands for material or mat. I don't know. And then we have the CV2.wait key. This is just going to say it's going to wait for the user to press a key, and it's going to close. It doesn't matter what key it is, it'll close. And then we have CVT.destroy all windows, which will destroy all the windows, ultimately closing it. So I'm going to play this all. Boom. We have this. We can press any key. I just pressed J on my keyboard. It closed and it destroyed all the windows that were up. And that is it. Okay. My next stream, we're going to be doing some more CV2 stuff. I want to thank everyone who has been following me, stuff like that. And I'm sorry I haven't been replying on comments. Not comments, Twitch replies. It's just that this thing isn't working. You guys are texting me. I can't see what you guys are. Sorry for that, Poflo. I'm sorry. The glory sauce. Yes. So in the next stream, I'll give you wiggle, 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 wiggle. I'll catch you guys in the next stream. And Poflo, we love you, man. We love your support. And ¿cómo se dice? Feliz días de la madre. ¿Verdad? Bye bye.